This video looks at how to sketch graphs with asymptotes. That's where the denominator of the fraction can equal 0. Now the first step is always to try to factorise where possible, and the top does factorise to become x plus 5 and x minus 5. So always begin by trying to factorise if possible. Right then, we'll begin by finding the axes' intercepts. So the graph cuts the x-axis where the numerator equals 0. So that happens where either x equals minus 5 or x equals plus 5. So therefore our graph cuts the axes at the values 5 and minus 5. So the graph will cut through in some way or other, which we'll find out about later on. There's also the y-axis intercept. Now that is where x equals 0, and if I let x equal to 0 in this expression, then I end up getting the answer y equals minus 25 over minus 24, or 25 over 24. So I've let x equal 0, pressed enter, and got that as my answer. So therefore the graph cuts through the y-axis at the value of 25 over 24. That's the y-intercept. I can also find the asymptotes. Now there are some vertical asymptotes. Now these exist where the denominator equals 0. So that is where either x equals plus 3, x equals minus 4, or x equals minus 2 over 3. That is where the brackets equal 0. So I can mark these on at 3. Again, so let me sketch this. So I've got a vertical asymptote, minus 2/3. This is not to scale. And also minus 4. This splits the graph into four different regions. And the question is what does the graph do in those regions? I can also find the horizontal asymptote. And to do this, you can try out large values of x. This is what happens to the graph as x gets large, positive or negative. And if I let x equal to plus 1000 into this expression on my calculator, then I get y is equal to 0.000333. So for large x, the graph is tending towards 0, but it's positive, so y is tending towards 0 from above. But if I let x equal minus 1000, then I get y is minus 0.000333. So again, y is tending towards 0, but it's happening from below, it's negative. Right, so I can now begin to sketch my graph, because I've got enough information there to begin to sketch key parts. Now the graph must cut through this point, but then it must also tend towards the x-axis from above. So it can't come down and back up again, that's from below. It must come up and then go back down again and tend towards the x-axis from above. However, on this side, it can't come up and then back down again, because it tends down from below. So it must come down and go back up again to approach the axis from below. So these are the two ends of the graph. I also know the graph cuts through this point, but does not cut through the x-axis. So it can't come like so, it must come from above and form a sort of a U shape in that part of the graph. So I've got that region done, that region done, and that region done. I've not yet got this region done. So there could be an upside down U, or maybe that U. And if in doubt, what you do is you pick a value just to the right of the asymptote, e.g. minus 3.9, and you put that in to the original equation, and see whether it is a positive or negative value. So if I put minus 3.9 in, it's negative, so therefore it comes from down here. If I also put, for example, minus 1 in, it's also negative, it comes from down here. So therefore the graph must come up, it cannot cut through the axis, there's no intercept there, so it must come up and then back down again. So that's my fairly rough sketch, which you might then redo more neatly, having got all the parts in place. But that is how you construct an asymptotic graph.